and this k nearest never decisions rule. It is very oldest decision rules. I think in 1950s. That at the time, this I don't really remember the name of the researchers who developed this rule. So they are simply design this rule and apply on the different data sets, and these data sets on this particular data set it was working fine. Then yes, then they are then people can adopt it had adopted this rule for this any other purposes, I mean for other purposes. But let me first explain the what exactly the nearest neighbor decisions rule, or mostly k nearest neighbor decisions rule is. So actually, as you can see in this in the k nearest neighbor decisions rule, uh, today I'm here to explain to you this what is the procedure to because it is actually a decisions rule for the supervised classifications first of all. And I'll explain to you that how the decisions rule can be framed to classify um, this for the classification purposes. Now let there's a xi and wi, as you can see. So let me just take this uh, highlighter, I think, not highlighter. Let me just take this pen. Now this xi and wi, that is a xi are the data points and wi are this classes. So xi data points, so you have this x1, x2, and this x3. These are the data points, and they are coming from these different classes w1, w2, and this wc, that I would rather say. And where xi is belong to rm. So means that is a I is equal to 1 to n. So this is a m dimensional real space. And wi, it's what is actually a wi. So wi, it denotes this is a level. So level means it is a class level of xi for each I. So x1 observation is coming from w1, x2 observation is coming from the w2, x3 observation is coming from the w3. So this way that we can think of it. So that is a wi denotes the level of the xi for each I. Now let us assume that you are given with a number of classes is c. You are given with c number of classes, okay, and where c is greater than is equal to 2. Okay, so at least you need to have two class for classifications. And where wi, that is a wi, this is an is element of 1, 2, and c for all. It means that is a if I'm going to have this w1 is 1 means first class. So and they, it means this observations, first observations or nth observation is coming from the w1. The wi is 2 means that is a second class. So now xi observation is coming from this w2, and w3 means xi observation is coming from the w3, and wc then xi observation is coming from the wc. So that is the meaning of this wi. Okay, I is belong to 1 to c. So wi 1 means xi observation is coming from the class 1. Wi 2 means xi observation is coming from the w2. WIC means XI observations are coming from the WC. That is the meaning. So this information is given to you. Now, let X be a point where the class level is not known to you. So you have to apply this k nearest neighbor decisions rule to classify this X. Okay, and we need to find this what is the level of the class. So we need to define what is the rule, what is the k nearest neighbor decisions rule to classify the X. Okay, so that is we'll just check it how these things can be done. Now procedure, first step, let k be the positive integer. So here we are going to have k be this, k will be this positive integer. So this k will be your positive integer. First step is k will be your positive integer. So how do you choose k? So that I'll explain to you later. Now steps two. Step two is calculate. You have to calculate this d. you have to calculate this distance between x to xi. Now what is this x uh, that we have to calculate? This is a I is equal to 1 to for I is equal to 1 to n, and where this d denotes this equilibrium distance. So this x is unknown, so you need to calculate this distance that is called the equilibrium distance between this all the points. So this is unknown points, this x. This point is to be classified, as I already told you. This level of the class is not known, okay, this x. And you are you are having a xi observation is given. Now this class level is not going to it's not given. Now you need to calculate the distance between x to all xi's. If you're if you're going to have the nth observation, if your n is equal to 100, then you need to calculate this distance from x to all 100 data points. Okay, so total 100 distances that you can calculate. So for all I is equal to 1 to n, where d denotes this Euclidean distance. So you are going to calculate only this Euclidean distance. You are not going to calculate any other distance to do this job. You are not going to use any non-Euclidean distance. So this is a step number 2. Now in step number 3, you have to arrange, you have to calculate n distances from x to xi. Then you have to arrange all the n distances in non-decreasing order or increasing order. So you have to arrange these n distances in non-decreasing order. Now in step number 4, you have to take the first k distances. You have to take the first k distances. So what does it mean? Now suppose if you are going to take k is equal to 1, then you have to take first least distances. If you are going to take k is equal to, because you are going to have the n distances, you have arranged it, and take first k distances mean if k is equal to 1, so you have to take first least distances. Okay, now if k is equal to 1, then you have to take the first distances. Now if k is equal to 2, you take the first two least distances. Now these two least distances may be coming from any one of the classes. Okay, so that's why this is called the take first k distances. Now find these k points. Now you have to find those k points corresponding to k distances. That you know that out of that many points, because k will be given to you, that how many points is corresponding to first k distances. So that information is given to you. So that's why you have to find those k points. Okay, that means how many points is belongs to if you are going to arrange it in an increasing order, that how many points is belongs to what this particular, what are the actually it is belong to the class representative. So these find k points means you are trying to find this class representative based on these minimum distances. Now, let Ki denote the number of points belonging to the ith class among the K points. So, out of these K points, you have to find these least distances which corresponding to particular Ki points, and you have to pick up that points only, and that points will be treated as a your class belongingness or the class representative. Then I is equal to 1 to c, then you can find whenever you are going to have, suppose I is equal to 1 to c, ki is equal to k, it means that suppose you are going to choose suppose k is equal to 3. Okay, okay, now sometimes it may so happen and you are going to solve this 3 class classifications problem or 4 class. Now sometimes it may so happen one class you may have 2 class representative, another class you have 1 representative, another 2 class there will be 0 representative. I mean 0 class representative. Whenever I am going to have this k1 is equal to 1, it means that first class you are going to have only 1 class representative. When I'm going to have k2 is equal to 1, okay, then this second class I mean k2 is equal to 2, then this second class I'm going to have this 2 class representative, and k3 is equal to 0, it means that there's third class I don't have any class representative. So k1 is equal to 2 means this first class I am going to have 2 class representative, means 2 minimum distances I have found for the first class. Now when you are going to sum them up, that k is equal to 1, then you are going to have, suppose k1 plus k2 plus k3 is equal to k. Now k1 will have class representative 2, so 2 plus k2 we have 1, and k3 will have 0. So k1 is 2 plus 1 plus 0, that is 3, and k is equal to 3. That is the meaning. Okay, so you need to find how many class representatives are there based on this minimum distance that you have already calculated. It may so happen, suppose if you are going to use these 10 classes or 20 classes, and you are going to choose k is equal to 1. Okay, now you have to calculate this distance from x to xi, and you have to arrange these distances. Yeah, if you are going to have only one distances, now somehow these distances is belongs to in the class 2 minimum, then your k2 is equal to 1, because as you are going to have only one representative, and k1 is equal to 0, k3 is equal to 0, and k10 is equal to 0. Okay, or it may so happen that this class representative will be maybe any one of the classes based on the distances, minimum distances. So minimum distances, maybe it belong to the class 1 or any class 2 or class 3. So this way that you need to understand how these things can work, and this is very important part here. And after that, you have to put x in this ith class, you have to put x in the ith class, because your objective is this x class level is not given to you. Your objective is to find the class level of the x, and you put x in the ith class if ki is greater than of kj for all j not is equal to 1, for all j is not is equal to I, because here you are going to have this majority voting techniques. Okay, so that is ki. It's what is the meaning of the ki is number of points, means number of class representative. Now if you see, if you are going to have the 3 class, okay, and in the first class you have 2 class representative, in the second class you have only 1 representative, then obviously the test pattern is going to classified in the class 1, not class 2. Or on the other way, if you are saying in the first class, k1 is equal to 1, k2 is equal to 2, and k3 is equal to 0, then in k2 is greater than k1, if you are going to find k2 is greater than k1, it means that in the second class we'll have the more class representative than first one. Then obviously this point will belong to the class 2, not class 1. But you see, here I am not going to use any equality sign. So I'll come to this point of why the equality sign is required. Now, this is a procedure for calculating the k nearest neighbor decisions rule. So k will be given to, I can choose k is equal to 1, k is equal to 3, k is equal to 5, and k is equal to 7. And you can just expand it based on these things. And you have to calculate this Euclidean distance from this x test point to all are the exercise points which is given. You arrange it in a non-decreasing order, and you take the first k distances, and then you find these k points corresponding to k distances, and you see that how many class representatives are there for this thing, and you just classify it based on this majority voting. So majority voting, it is nothing that how many class representatives are there for this particular class, and if these classes will have the more class representative, then the test pattern will be classified on this particular class only. This is called a very simple way to understand this is a k nearest neighbor. Now in the pictorially that I can just show you, as you can see, I'm going to have these 3 classes. This is class 1. Class 1, I'm going to have the 4 data points, 1, 2, 3, 4. This is 4. And class 2, I'm going to have how many data points? Four data points. And class 3, I'm going to have how many data points? 5 data points. So total how many? Total number of points how many? 5. 4 plus 4 plus 5. Total 13 points are there. Now this is my test pattern x. As you can see in this diagonal, this is my test pattern x. So my test pattern is belongs to here. Now I am going to choose k is equal to 3. As you can see here, this n is equal to 13 and k is equal to 3. Now what you have to do? So you have to calculate the distances between this test pattern x to all the 13 points. So how many distances you are going to get? You are going to get this 13 distances from the test pattern x to all the training patterns. Okay, and you are going to have the 3 classes. You have to arrange all the distances in an increasing order, and you have to take the first 3 smallest distances. Why 3? Because as you're going to choose k is equal to 3. If you choose k is equal to 5, you can take 5 smallest distances. Now, from these smallest distances, what you have to do, you have to just check that whether these things is going to be classified or not. I can just check it. Let me just yes. Now I can that you can see that you need to we need to check. That is a how we are going to check to take the decisions. Now, as you can say, in these points, so these points is very closest to that these points in this class 3. So obviously, so this point k3 will be 2. Why k3 is equal to 2? Because these points, this test point is closest to this point, so obviously, so this class will have these two class representative. Similarly, these points, this class will have only one class representative. Why? Because these points only this closest to this point. So total how many class representative of the there for the first class? So based on these distances that have been arranged, for this class 1 you have only one class representative. Class 2 there is no class representative, means k2 is 0. So k2 is 0 means there is no class representative. K1 is 1 means for the first class you have only one class representative which is closest to this pattern. K3 K3 is 2 means that is that these points, this class will have two class representative. Now you just sum them up, that I is equal to 1 to n, that is a ki is equal to k, then 2 plus 1 plus 2 plus 0, I mean 1 plus 0 plus 2, then you can get the 3. So this way that you can take a decision. Now if somehow, if I'm going to use here, now just look at this point. This is a, if ki is greater than is equal to kj, then what is the situation that you are going to, how we are going to address this situation? Now ki is greater than is equal to kj. Suppose if I'm going to have a another class representative, suppose here, suppose I'm going to take, so this is my another class representative. So means I'm going to have k3 is equal to 2, k1 is equal to 2. So both are equal, because both the classes have the equal number of class representative. Then how we are going to take the decision that test pattern will belong to the either in class 3 or in the class 1. So that's why we are going to choose this odd number of k values in order to avoid the tie, or there is a situation that if there is a situation, if you are going to have even number of k values, and if that situations that if both the classes will have equal number of class representative, then you have to arbitrarily put these points, put the test pattern in any of these test classes, either in class 2 or either in the class 1. So here we do not need to know any prior probabilities. Now you see, this is a very simple rule. We do not need to know any prior probabilities, not even any class conditional density functions that we have already calculated. But this rule is obtained from a density estimation rule. So there is a, so this k nearest neighbor dense rule that has been obtained from k nearest neighbor density estimation procedures. Okay, now there are certain remarks of this knn. First one is that how do you choose the value of k? This is the first question. Okay, second question is, if you are going to choose, if you are going to change the value of k, so it is not necessarily true that you will get the same result. For the different values of k, you will have the different results. Okay, now if you're going to, if you're going to have the different values of k, if you're going to have the different values of result, then what will be the optimal values of k to choose? So now for the choosing these optimal values of k, so this is a one way is called the cross validation technique. You can apply the cross validation technique and to choose these optimal values of k. And this rule that there will not have any mathematical way, like the base decisions rule that you have already seen. There is a mathematical theoretical justification of these things, but here there is no as such a theoretical justifications of these things. How do you choose the value of k? I am using this data set for this data set. This my k is equal to 3 is okay, but I am going to change the other data set. This k is equal to 3 is not okay. So there is no generalized way to declared that for this is the optimal values of k of this thing. But somehow some mathematical way to understand this k nearest neighbor rule by the k nearest neighbor density estimation procedure, and this k nearest neighbor density estimation procedures was being discovered that in 1965 was Loft Gardens. Okay, so they proposed this concept, that is a this Kenian rule can be derived from this k nearest neighbor density estimation procedure. So what is the k nearest neighbor density estimation procedures? As we can see, there is a x1 to x1 to uh, x1 to xn. These are the x1, x2, x3, xn. These are the actually it is a observations, or you can say it is a random variables. X1, x2, x3. These are the random variables, and that have been drawn from a unknown distribution P, and you have a P that you need to, which is unknown. P is a density estimation. P is a density function, and or which follows some distribution, and it is not known to you. Now you have to estimate it. Now this x1, x2, xn, these are the random variable which is independent and identically distributed random variable, and it has been drawn a distribution that is p, which is unknown to you. Now what is exactly this? So I'll just ask you these questions, that if this data point is given, one dimensional data point is given in the table, now how we are going to classify the test data? This is for your assignment that you can check. Assume this one dimensional data set is given in the table, and you have to classify the test data based on the your test data point x is equal to 5.0, and here this class level is not given to you. Baki for the other data points, the class level is given. You have to apply one nearest neighbor, three nearest neighbor, and the five nearest neighbor, and the nine nearest neighbor, and you have to use the majority voting. How you are going to solve it? So you can take it as an assignment, then you can do it. I'll also tell you how to solve it. So before that, let me just explain you. This is a nearest neighbor decisions rule. That I'll just come to this point afterward. Now, what is the procedure of this nearest neighbor decisions rule? Now, this k be a positive integer. So what is the procedure of estimating these density functions? What is the procedures for estimating this density function P? So because x1, x2, x3 have been drawn randomly with a unknown distribution, your objective is to estimate P. How to estimate P? So for these things, this is a k be a positive integer, and we need to estimate the density function. We need to estimate the density function x, okay, where x is belong to Rm. You have to find the k nearest neighbor of x among x1, x2, and xn. So you need to find this k nearest neighbor of x among x1, x2, and xn. So now let r be the r denote the distance between the x and its nearest neighbor. So they are going to calculate, because you see it is a multi-dimensional data, and you are calculating these distances of x, your where these are denote the distances between the x and its nearest neighbor. Okay, and whenever you are going to calculate these distances for all the data in the multi-dimensional data points which are given, and so this function, so actually it is a uh, density function, and for and if you have the density function in this multidimensional, and you can find that calculating the distance between x to its nearest neighbor, then you are going to find a volume. Okay, and this volume, it is a nothing but of a of n in r comma m. So this is a volume. So where r is, so m is a dimension, where r is the radius, and r is the function of n. So n is the total number of data points. So r is the radius, and using this radius on this m dimensional space, you are just drawing, or you are just going to design. Now whenever you're going to calculate the distances, then you are just going to denote this volume of a disk of radius r in d-dimensional space. Okay, so that volume that you are going to have, and from this volume you have to estimate the density you have to estimate the density at x, which is denoted by, whenever I am going to use estimated density, you are going to have the p hat x. Okay, so one density is given, that is a from the known distribution, that you can calculate this density, where there is no estimation is given. But from the data points, as I already told you, from the data points you can easily estimate the density, and this density that you are going to estimate, that is called the k nearest neighbor density estimation rule. Okay, which will allow you from to calculate this density estimation, and from this density estimation rule you can establish this k nearest neighborhood. So that's why this estimated density at x, which is denoted by p at x, it is nothing but k by n, or you can simply write k by n by a n rm. So now it is just a volume. So this is a volume a of n rm. So this is a volume where r is a function of n. So you are not supposed to write every time this n, because r is a function of n, m is the radius, and you can design d dimensional space. This volume can be constructed, and k by n. So what is the meaning of k by n? So out of the n points, you are choosing the k points. So that is the meaning of k by n. So now if you see this density, now you can just, I mean, understand this density, it is a nothing but a mass by volume. That we have already studied in our school level mathematics, school level physics course, that is a mass by volume. So this mass is nothing but k by n. So k by n means out of the n points, that how many k points is going to be choose from this volume, and a n rm means it is a volume. So this is a nothing but a estimated density, and this density can be estimated with certain rules. So what are the rules? This k is a function of n. We shall denote it by kn. So k is a function of n, because n is a number of points. From this number of points you have to choose this k. We shall denote this as an kn, and this kn is tending to infinity, when, because you need to have a law of large number, you need to have a this sufficiently large values of n, then only you are going to have, and this is will be have a asymptote. This p hat of x is asymptotically unbiased and consistent estimate of p. So your p is given, and from this thing you are going to estimate it. Whether your estimated density is close to the actual density is not. So in order to prove it, you need to have a asymptotically unbiased. What is the meaning of the asymptotically? Because when n is tending to infinity. Okay, so that is called the asymptotically. So unbiased means that is your actual population is estimated value is equal to the actual value. Then this is called the unbiased. And that is kn is tending to infinity as n tending to infinity. And whenever kn tending to infinity, then kn by n is tending to 0 as n tending to 0. If there's a two condition. First condition is kn tending to infinity as n tending to infinity. This is one condition. Second condition, kn by n is tending to 0 as n tending to infinity. Now, if the condition on 2 are satisfied, if the conditions on 2 are satisfied, and x is a continuity point, x is a continuity point in the density function p, okay, or it is actually in the density function, it is a continuity point, then px is necessarily be asymptotically unbiased and consistent estimate of p. Now you can have this px, p hat of x, I can write k of k by n ar. Now this p of p hat ix, that I can write, I can increasing these values of I, for if you have the n number of observation, then ki by n into air. So it is just nothing but it is a mass by volume, that I'm going to write it over here. Now what was the base decisions rule that we have already studied? The capital pi small pix is greater than is equal to capital pj small pjx for all j is not is equal to I, that we have now studied. Now you just put this pi. Okay, this is estimated prior probability, this is estimated density, this is estimated prior probability for the another class, estimated density for the other class. Now as I already told you, if this prior probability is not given to you, from the training data points you can estimate the prior probability. How we are going to estimate? That is ni by n, because you are just going to have a mixture probabilities, I mean mixture density from the mixture density you can take randomly n1 samples from n and n2 samples from n. Then what is the prior probability for the first class? N1 by n and n2 by n. Here I am denoting these two classes by ith class and the jth class. First class is the ith class, second class is the jth class. That's why I'm going to write ni by n for the first class. This is my prior probability, and pi hat x. So this is a nothing but a estimated density which you have already calculated. What is it? That is ki by ni into ar. So this is my estimated density for the first class. Now this is estimated density, estimated prior probability for the second class, nj by n multiplied by kj by nj into r. Now you just do some cancellation of the term. You can only have, so this will be constant, this will be constant, and this can also be same for this both the classes. I can only have ki is greater than is equal to kj. Now what was our k nearest neighbor rule that you have already studied? So this k nearest neighbor rule was, what was my k nearest neighbor rule that we have already studied? So this was my k nearest neighbor rule, ki is greater than is equal to kj. So this ki is greater than is equal to kj, so that you can establish, or somehow you can manage to establish a theoretical justification from this k nearest neighbor density estimation procedures. From the k nearest neighbor density estimation procedure, you can establish a k nearest neighbor rule, decisions rule. Okay, so that was a very interesting mathematical concept, and this way you can prove it, that the way that I was explaining to you. You have to do a lot of assumptions that your density function is not given to you. You have to estimate the density function, and whenever you are going to calculate the distances, you are going to make a one disk volume of the disk of the radius r, and you have to calculate this density in the form of a mass by volume, and you plug into a base decisions rule. From the base decisions rule, you can calculate it, k nearest neighbor decision rule. Now we'll solve this problem. Classify. Suppose this data point is given. You are going to have a one-dimensional data set in table 1. So this for each points, this class level is given. For the how many points you are going to have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 points are there, and these are the, you're going to have these two classes, positive class and the negative classes, and each point is there. Now you have to classify the test point, x is equal to 5.0, and that is given, and you have to apply first nearest neighbor rule, third nearest neighbor rule, fifth nearest neighbor rule, and 9 nearest neighbor rule using this majority voting technique. Okay, now this you can find this answer. If you are, you can solve by yourself also, and then you can find this k nearest one nearest neighbor if you're going to apply it. So this point is belong to the positive class. If you're going to use this three nearest neighbor, as I already told you, if you are going to choose the different values of k, then it is not necessarily true that you can have the same results. You may have the different values of k, you may have the different results. So that is the and then from the 10 distances that I have arranged it, you can arrange it in a you can arrange these 10 distances in a increasing order. Okay, and then after that you can apply these classification results, and you have to choose that first NN that you can, this points is belongs to the positive class. In the third NN that you can have, because you need to apply this whenever you are going to use this third one NN, you are going to have only this least distances that you can have, and it is positive class. Then in the third NN you can have, that is a, I mean this is a uh, I mean 4.9, this is a positive, 5.2 is a negative. Then as you can see, there are two class representative is there in this, in the negative class or the second class. So this point is belong to this in the negative class. So similarly, if in the 5 you have to choose this, what are the maximum class representative is there. As you can see, there is a positive class. You are going to have the three class representative. Then you have to apply the majority voting technique. For this plus is 3 and minus is 2. Then this prediction is plus 2. Similarly, for the 9, you can have, that is a for the negative class, you have this 5, 1, 2, 3, 4, 5 class representative is there, and for the positive class you have 4. Then obviously it will be also classified in this is a negative class. So these are the way, and there is a means whatever I have discussed, so it is there. That is a, you need to have the three things: the set of stored pattern, and you have to find the distance metric to compute the distance between this pattern, and the value of k means number of nearest neighbor, and this already explained. You have to apply this Euclidean distance, and this k is equal to 1 then belongs to the square class, k is equal to 3 is belong to the triangle class. I mean, you can just check how these things can be varying. K is equal to 7, it belongs to the square class. Similarly, now if you are going to choose a very small values of k, if k is too small, then it is sensitive to noise point. And if you are going to choose this k is too large, then this neighborhood may include points from the other class also. So that you have to choose this k in a marginal values of k, that you have to choose, so that it should not be too small and it should not be too large. So we have to choose this is say odd values for k in order to eliminate these ties. So these are the things I already explained. So there is a different advantage of this KNN. The simple technique that is easily be implemented. This building model is cheap. This is extremely flexible classification scheme, and it is well suited for multimodal classes. And this error rate at most twice that of the base rate. So this is a very good paper you can refer. That is a cover and hard paper in 1967. It can sometimes be the best method that we can use it. And there is a few disadvantages are there. There is a, you have to classify these unknown records are relatively expensive. Okay, because you need to calculate, requires the distance computations of the all the k nearest neighbor. It is computationally intensive, especially when the size of the training set is too large. Okay, then you have to always calculate the distance, and it is only work. Mind it, this KNN, the distance function is a Euclidean. It is not a non-Euclidean. This distance. This accuracy can be severely degraded by the presence of noise. Obviously, there is a great disadvantage if any noises or irrelevant features are there. Then it is going to be degraded. So these are the things. And before just starting in the next session, I just quickly give it to you this, because I'll in the next session, so I'll be explaining to you how this image classifications problem can be done based on the satellite image. But before that, I'll just request everyone to download these iris datasets, because the implementation based decision tools and KNN implementation only on iris dataset. I'll show you this Python code which we have written, and you have to just see and implement it. And before implementation, that you just have these requirements. There is a, you have to have Python version is 3.8, Python packages just install NumPy, Pandas, scikit-learn, and Skype. And to install this Python, there's a link is there. I'll share this PPT to Hansen now. After this session is over, you can follow this PPT. And I mean, this download, you can download it. And for Python packages, you can comment this pip install package name, or you can use the Anaconda also to do this certain task. And this data set, it is very common data set. There is a three classes. There is a Setosa, versicolor, and this is a Virginica. There are four different features. I mean, this is sepal length, this is a sepal width, petal length, and petal width. Total 150 samples in total. Each class, I mean, each class will have the 50 samples. So base decisions rule means whatever I have discussed, that is a probabilistic classifier. That's base theorem. You have to I mean, classify a sample to this class that maximize the posterior probability. You can simply apply this formula, and you have to find this which will have this maximum value, and that's R max of P of X given Ci into Pi. Okay, and this is a decisions rule that you can apply, and you just load the data using this sklearn dot dataset dot load iris, then split the dataset into 70 is training, 30 testing, or you can have 80 into 20, no problem. You have to extract uh, feature X and the level Y, that you can extract it. And parameter estimation for each class, you have to compute this prior probability first. You have to compute the mean of the features. You have to compute this covariance matrix, which I already explained. Then assume that each class is following multivariate question, you have to calculate this formula. What was the formula? 1 by root over 2 pi to the power m, determinant of sigma to the power half, exp of minus half, x minus mu transpose, sigma inverse x minus mu. So these are the formula that you have to implement it. How to implement it? I'll explain it in the next class. And then after that, you have to classification using Bayes rule. For each test sample, you have to compute likelihood. Okay, compute the posterior, then assign this class to this highest posterior value. I mean, capital Pi, small pi is greater than or capital P is small pi. That's it. If you are going to assuming this I mean all the classes are this equiprobable, then only you have to consider the likelihood function. Then you have to predict this level for the test data, and you have to evaluate this accuracy, and you have to calculate this precisions, recall, and inference score. This is a standard measure that you can show it. So these are the things that you have to do it. And for this KNN is a non-parametric instance-based learning, and it makes prediction using the majority vote. I already explained. And no training, it is just store the training data. So these are the steps, very simple step that I have written. Load the data set first, split the data, 10 test, define custom KNN class, use equilibrium distance for similarity, then predict this using the majority vote, and evaluate using this accuracy, precision, recall, and inference score. So that's it. So if you have any questions, so you can ask me. So this is for this second session, and next sessions I'll explain to you this how these two things can be implemented. Before that, I'll sharing this PPT to Hanser. Hanser can share all the participants for their reference. So yes, so this error rate is twice than this base rate. Yes, so there is a it means it is not this better. So there is a proof. I'll share it this PDF file. From this PDF file you can have, there is a derivation is there. So there is it is not better than this KNN. I mean base is so there is a proof that if you are going to have a decisions rule, and if you somehow you can prove that is a error rate is this twice, this is a base error rate. So there is a proof is there. There is a proof is there in this PDF file for this hearts and coverts. So the hearts is called, that is a, if you see the pattern classifications book, na Duda heart. So from this Duda heart, so this is the name of the heart. So yes, so it is just a twice the base rate. So it doesn't mean that base is better than that is in care. Obviously, this base rule uh, is it is said to be a this base decisions rule. Why the base decisions rule? You can apply any damn decisions rule, and if you can prove that this rule is less than the base decisions rule, then this decisions rule can be a base decisions rule. Similarly, if you can prove this KNN, that if you this the misclassification error rate of this KNN is lesser than that base decisions rule, then yes, obviously this rule is better than this rule. So there's another way of these things. Okay, so for this thing, so I'll just if the time permits, we'll just I think this recall precision upon score confusion matrix. So I think, sir, there will be some separate sessions, or shall I need to discuss in the afternoon?
No, no, sir. There is a one separate session, not today, but in a in a day in between this first two and separate session. This recall precision F1 and confusion matrix. So, Mr. Panda, so please you don't worry that we will have a separate session for this. Uh,
Okay. Okay, sir. I'm just sharing you these two slides. You please share with these participants so that they can just see this thing. Okay, sir.
sure, sure, sure. Thank you, sir. Thank you for giving the insightful lecture. So, actually, in this course, the prerequisite is uh, a participant that should have little bit idea of the linear algebra, statistics, and some sort of probability.
Yes, sir.
Only-
Correct.
Then only they can take this to the next level. Otherwise, very difficult to connect all the lecture and all the theory and mathematical expressions and related intuition. So that is the one thing that the participant that should have the little bit knowledge of algebra and statistics. So,
Yes, sir. So, and just moreover, this thing is that I'll just in the laboratories success, and it is also very difficult to see the type the code and other things. So, because many participants are new, so it's better I'll give it to the some implementation procedure, how to implement it, each and every steps I'll explain to them using the images with some calculation. Then when they I mean get accustomed with the entire sessions, and they will able to follow up this all the materials. Obviously code I will be sharing the code also. Hmm. But only showing the code and just copying the code from me and
yeah,
just writing, so I don't think so they will learn something new. So
yes,
it's
sir.
better if I just tell them these implementation steps from I mean each and every steps. Okay,
Yeah,
how to start it and how this. I think that will be beneficial to the participants, I think.
absolutely, sir. Absolutely, yes,
Okay,
yes,
so sir, in the I'll start with the at 2 o'clock. I'll take the lunch and just try to implement the base, how to implement the base decision on the satellite images as well as in the KNN. Okay,
yes, sir. Now take your time, sir. Yes, we will start at 2 o'clock, sir. No issues.
2 o'clock, and I'm just sharing these slides to you, sir. You
Yes,
please share with them. Okay,
sure, sir. Sure. Sure.
thank you,
Thank,
sir.
thank you very much.